Welcome to Engineering Simple. This is part 3 of finding limits. So this is another set of limits. And again, I'll just go back to here's the definition. The limit of f of x as x approaches a is equal to L. So this is how it reads. So limit of f of x as x approaches a is L. So here's another set. So what is the limit of quantity 2 times x plus 1 divided by x as x approaches 1? So again, the same kind of concept, just write it out, meaning the function you're trying to evaluate the limit for. So it's 2x plus 1 divided by x. Then just replace x with 1 and see what you get. So again, 2 times 1 plus 1 divided by 1. So 2 times 1 is just 2 plus 1 divided by 1. So 2 plus 1 is 3 divided by 1. 3 divided by 1 is just 3. So this is the solution. Now let's find the limit for quantity 3 times x minus 2 divided by quantity x plus 2 as x approaches 0. So again, let's just write out the function or the equation. 3 times x minus 2 divided by x plus 2. Then basically, wherever I see x, I'm just going to replace it by 0 and see what I get. So 3 times x, so 0, minus 2, x plus 2, so 0 plus 2, equals, so 3 times 0 is just 0, minus 2, 0 plus 2 is just 2. So 0 minus 2 is just minus 2 divided by 2. So negative 2 divided by 2 is just negative 1. Now let's go to the next example. So let's find the limit of x plus 4 divided by 2 times x squared plus 2 as x is approaching negative 1. So again, like always, x plus 4 divided by 2 times x squared plus 2. So the first step, you write it out. Then literally, you just go through and replace x with negative 1. So negative 1 plus 4. Then I have 2 times x squared, so negative 1 squared plus 2. So negative 1 plus 4 is 3. 2 times, so negative 1 squared is just 1. So 2 times 1 plus 2. So I have 3 divided by, so 2 times 1 is just 2 plus 2. So 3 divided by, so 2 plus 2 is just 4. So 3/4. So here's another example. So we're trying to find the limit for x squared plus 5 divided by negative 3 times x cubed plus 2 as x is approaching 1. So the first step, just write out the equation. So x squared plus 5 divided by negative 3 times x cubed plus 2. Then wherever you see x, just replace it with 1. So basically 1 squared plus 5. Then I have negative 3 times x cubed, so 1 cubed plus 2. So I have 1 squared is just 1 plus 5. So negative 3 times 1 cubed is just 1 plus 2. So 1 plus 5 is 6. Negative 3 times 1 is negative 3, then plus 2. So 6 divided by negative 3 plus 2 is negative 1. And as I stated before, we don't like negative sign to be in the denominator, so I'm going to take it up by multiplying up and down by negative 1. So negative 1 times 6, negative 1 times negative 1. So basically this is what I multiplied. So I multiplied both sides by negative 1, so that way they cancel out. So now negative 1 times 6 is negative 6, so you can see how the sign changed from 6 to negative 6. The negative 1 times negative 1, so negative times negative is plus 1. So you can see how the sign changed from negative 1 to 1. So negative 6 divided by 1 is just negative 6. So now we're trying to evaluate the limit of x cubed divided by negative 3 times x to the power of 4 plus 2 as x approaches negative 2. So the first step, you write out the equation. So x cubed divided by negative 3 x to the 4th power plus 2. Then wherever you see x, replace it with negative 2. So negative 2 to the power of 3. Then you have negative 3 times, so negative 2 to the power of 4. So that's all I'm doing here. So you see, instead of x, I put negative 2. So since I have a negative sign and I have an odd power, so it's going to be negative. 2 to the power of 3 is 2 times 2 is 4 times 2 is 8. So negative 8. Then I have negative 3. Since I have a negative sign here and I have an even power, so I know it's going to be positive, so plus, I'm not going to write it. 2 to the power 2 to the power of 4 is 16 plus 2, so negative 8. So negative 3 times 16 is negative 48 plus 2. So is equal to negative 8 divided by negative 48 plus 2 is negative 46. Since I have negative sign at the top and the bottom, I can just ignore them, cancel them basically. So 8 divided by 46. And if you want to simplify, divide both sides by 2. So 8 divided by 2 is 4. 46 divided by 2 is 23. So now so I'm trying to evaluate the limit of x cubed minus 1 divided by x minus 1 as x is approaching 2. So basically I'm just going to write out this formula or equation by x minus 1. So notice here, and I would recommend watching video on remarkable identities. So this here, so x to the power of 3 minus 1 is the same as x to the power of 3 minus 1 to the power of 3, which is in the form of a to the power of 3 minus b to the power of 3, which is a minus b times a squared plus a times b plus b squared. Yeah, I would recommend watching the video on remarkable identities. That's basically what I did here. So basically I can rewrite this so as x cubed minus 1 cubed divided by x minus 1. So in my case, my a is x and my b is 1. So I can write as x minus 1 times a squared is basically x squared in my case plus x times 1, which is x, plus 1 squared, which is just 1, divided by x minus 1. So notice x minus 1, they cancel out, and I end up with x squared plus x plus 1. So then I just replace x with 2. So 2 squared is 4 plus 2 plus 1. 4 plus 2 is 6 plus 1 is 7. If I want to check in this case, so if I just go here, I have x cubed, so 2 cubed minus 1 divided by 2 minus 1. Basically, I'm just taking this quantity here and replacing x with 2. 2 cubed is 8 minus 1. 2 minus 1 is 1. 8 minus 1 is 7 divided by 1, which is just 7. So I get the same value. However, this here is important to know, because if x was approaching 1, you would have to use this, because if you replace 0 minus 1 is, if you replace x with 1, so 1 cubed is 1, minus 1 is 0, 1 minus 1 is 0, 0 divided by 0 is not possible. But you would have to go through this identity here, because now once I simplified it, if x was approaching 1, then I can replace x with 1, then 1 squared plus 1 plus 1 is 3. So let's evaluate this limit here. So basically I'll just rewrite this quantity here, plus 4x plus 4 divided by x plus 2. Again, if I notice, this here is an identity which is similar to a squared plus 2 times a times b plus b squared, which is equal to a plus b squared. So I would recommend watching the video on remarkable identities. So I can rewrite this as, so x is already squared plus, so 4x, I have 2 here, so I want to do 2 times something that would give me 4x. So times 2x plus 4, which is 2 squared, divided by x plus 2. So basically, I wrote this here such that it's in this form. Something squared plus 2 times something something plus something else squared. That's what I did here. Now I can go ahead and use this simplification here. So it's just a plus b quantity squared. So my a is x and my b is 2 squared divided by x plus 2. And we know x plus 2 quantity squared is the same as x plus 2 times x plus 2, right? So I can cancel one of them and I end up with x plus 2. So I'll replace x with 1, which is 3. Again, this is important to know because if x was approaching -2, because you know x plus 2, if I replace x with -2, -2 plus 2 is 0. So, and you know you cannot divide by 0. So that's why it's worth knowing this identity here. And this video was kind of just going through kind of basic on how to do ratios, but the complexity of the limits is going to increase, and at some point we're going to come to basically evaluating kind of similar quantity where the denominator goes to 0. And how do you do that? How do you solve that? Is by going through this simplification here basically. So that was it for this video. For more videos you can go to Engineering Simple. Thank you and have a great day.